Hello students, in this video I am going to go through some examples on how to graph the equation of a hyperbola. So let's take a look at the first example over here, question number 1. Alright, so this is the equation for a hyperbola, and the general equation for a hyperbola, okay, very similar to that of an ellipse, looks something like this. Whoops, not 15, because I'm speaking in general terms. And it looks very, very similar. So by inspection right now, okay, the way in which this equation is presented to us, the center has got to be located at 0, 0. So immediately I can tell where how the hyperbola is going to be oriented. It's going to be at 0, 0. The next thing that I need to do is I need to identify where some of the intercepts are. So looking at this, okay, if I try to find out what the x-intercept is, okay, I can substitute in 0 in there. And what I will end up with is an x-intercept of plus or minus square root of 15. So what exactly is square root of 15? So square root of 15, if I go back to the calculator over here, square root of 15 is roughly 3.9, so it's like roughly 4 almost. So I want to say it's going to be like right there, okay? And this is just approximating, okay? Because there's no way of getting it to be exact. I'm just getting a rough sketch of this, okay? So it's going to be plus or minus square root of 15. Now, what if I try to find out whether or not there are any y-intercepts? I can do that, okay? So if I substitute in 0 in here, we'll end up with negative y squared over 20 is equal to 1. Or y squared is equal to negative 20. And this is not possible on a real number system, which we have here. This is a Cartesian grid with real numbers. So therefore, we cannot graph anything that is imaginary. Even though, yes, there are technically roots, okay, we cannot graph them on the same set of axes with real numbers. So because of this, okay, we're only going to have x-intercepts. All right, so now that we recognize this, okay, there's one other idea that was not brought across in the derivation video, and that is there are a set of asymptotes, okay, that the hyperbola will try to approach but never quite reach, okay? The asymptotes, okay, will have a slope of, not y, will have a slope of m equal to plus or minus b over a. So whatever the a and b values are, okay, the slopes of the asymptotes will be of that ratio. So what is that? Well, looking at this right now, a is equal to square root of 15, and b is equal to square root of 20. So in this case, the asymptotes will be square root of 20 plus or minus square root of 20 over square root of 15. And what is that approximately equal to? This is the same thing as square root of 20 over 15. And there's a common factor of 5 that goes into both 20 and 15, right? So this is really square root of 2 over 3. And what is square root of 2 over 3 roughly? Square root of 2 over 3, if I punch that in, square root of 2 divided by 3, that's roughly 0.8. So in other words, okay, because it goes through the center, my asymptote will also go through the center, and the line, the slope that I get will be roughly something like this, where it's not quite 1, it's something under 1, which is what I'm trying to do here. I'm graphing something like that, okay? And I'm going to go in the other direction. It's going to be something similar. So it's not quite 1. It's going to be something under 1. And the graph of the hyperbola is going to be within those bounds of the asymptotes that I drew. Okay, so again, what exactly is the asymptote doing? It's telling us that the graph is going to approach those dotted lines, but never quite reach it. So it's going to look like this. Okay? Let's take a look at another example where the numbers are a little nicer and a little more forgiving. All right. Let's take a look at this one. Here in this case, we can identify what is the center of the hyperbola. The center of the hyperbola is located at k, right? Which in this case is 2 comma negative 1. So if this is 2 comma negative 1, okay, why don't we try to, well, we can figure out also what a and b is, right? So I know that a squared, this is a squared, and this is equal to b squared. So what is a and b? So a in this case is equal to 3, and b is equal to 3. And the slope is equal to plus or minus b over a. So if I substitute in what a and b is into that slope formula there, okay, I'll end up with plus or minus 1. So this one here is a little more forgiving. So if I do this, okay, I'm going to put in the dash line, passing through plus or minus 1 exactly now. Okay. And over here, same thing. And over here. All right. And what I can do, okay, is actually, no, I apologize. The center is located at 2 comma negative 1. Sorry. So I got to redo this. So the center is located at 2 comma negative 1. So 2 comma negative 1 is located over here. And again, I'm going to draw in the line with a slope of plus or minus 1 through this. So I end up with something like this. And I end up with a asymptote going through there. And extending. All right. And I know that the hyperbola, okay, if I substitute in negative 1 in here, okay, I'll end up with x minus 2 quantity squared over 9 is equal to 1. I'm going to multiply both sides by 9 and end up with x minus 2 squared is equal to 9. Take the square root, I end up with x minus 2 is equal to plus or minus 3. Add 2 to both sides, I end up with x is equal to 5 or negative 1. So 5 or negative 1. So in other words, those are my vertices, and my graph is going to hug those asymptotes, and that's how I generate the graph of that hyperbola. Let's take a look at another example. This guy right here. So what I want to do, okay, with this, again, very similar. Rather than pinpointing the equation for, not the equation, where the center is, okay, what I can do is I can figure out where the X-intercepts are before I do that. So if rather than substitute in 1 in here, right, we can actually think of this as the same graph as x squared over 25 minus y squared over 9 equal to 1. If I find out where the x-intercepts are, from there I can then shift everything, right? So it's very similar to that quote-unquote trick, okay, that I did in the previous video involving the ellipse. So from this, okay, if I substitute in 0 in for y, I end up with x is equal to plus or minus 5, right? So in other words, okay, the center is located at 0, 1, right? So 0, 1 is located over here. I want to move to the left 5 and to the right 5 of that center. Notice I don't have to worry about, like, you know, taking the square roots or anything, okay, if I do this. And similarly, I'm going to find out what is the slope of the intercept of this asymptotes. So m is equal to, again, plus or minus b over a. Looking at this, I know that b squared is equal to 9 and a squared is equal to 25. So therefore, b would have to equal to 3 and a would have to equal to 5. So I have plus or minus 3/5. So that means I'm going to go up 3 and over 5. down 3, and over 5. So my graph, or the asymptote, is going to look like this. I want to do the same thing, over 5 and down 3. And same thing over here. And over here like so. Okay? So the graph is going to look something like this, where, again, it just passes through that vertex and hug the asymptote. Passes through the left vertex and then hug the asymptotes. So that's the graph of the hyperbola. Let me see if I should do anything else from here. Whoops. Looks like the rest is very, very similar, so I'm going to stop here.